Good morning, class. Our current unit is on relations and functions. So, our main idea here in this video is when is a relation a function? We have to answer first, though, what is a relation? Okay, so a relation is a relationship between sets of information. So, in math, this is the relationship between inputs and outputs. Of course, if there's a relation between two things, they are connected, they are related. Okay, so think about it like that. And here are examples of relations expressed in multiple ways. So here we have a table where we are relating the car make with the model. Here we have a graph. And then we could also have this, what we call a mapping, where an input is being mapped to the output. We can also have a formula or an equation. Okay, we could also have it in words. So this one is in words. This is also another example of relation. It relates the height of a plant with how much sunlight it gets. And this one is the last one is using ordered pairs. We can represent relations using ordered pairs. In this case, our inputs are the states. Actually, these are New England states, and the outputs are the number of electoral votes each state receives. Okay, so here are multiple ways to represent a relation. Again, a relation is just really a connection or a relationship between an input or inputs and outputs. Now, there's a special kind of relation, and we're going to see it. We're going to see it through a vending machine, which is what we call a function. So a function is a relation such that for every input, there's exactly one output. Okay, a function is a relation, but it's a special relation. And like I said, let's differentiate these two, a function and a relation, using vending machine. So in this vending machine, for example, this vending machine represents a relation. The reason for that is because, again, the definition of a function is there should be one output for every input. Okay, exactly one output. The problem here is if I put in E1, okay, if I select E1 from this vending machine, the problem is I could have cookie. I think that there are two here. I could have cookies. I could have Fritos. I could have Cheetos. Okay, because they're all E1. I could have Munchies, and I could have Hickory Sticks. So this one is not a function. Okay, if this was a real life vending machine, if I pressed E1 on this vending machine, it's gonna have a problem. It's gonna malfunction because it would not know what I want. Okay, so that's how I usually represent a relation that is not a function. Okay, a relation that is not a function is like a vending machine that is malfunctioning. It would not know what I want if I pressed, in this case, E1. Whereas, say I fixed this, I renamed the E1s into different inputs. So say I call them E1, E2, E3, E4, E5. Now, this is a well-functioning vending machine. No matter what button I press or what I input, say I put in E1, E2, E3, E4, E5, it would know what I want, because if I pick E4, it knows that I want Munchies. If I picked C2, it knows that I want Smart Food popcorn. Okay, so this is a function because for every input, okay, E1, E2, E3, E4, E5, and then these C's, there's exactly one output. So think again of these vending machines when you're trying to figure out if a relation is a function or not a function. Let's say this is presented differently. So again, we can represent this using a table. Now, notice this is a function. This is not a function. And the reason is, in the table, here are the inputs. And as you can see, if you pick Toyota, you know it's Corolla, Nissan, it's Sentra, Honda. The output is Honda, the output is Civic. And then if you pick Chevy, the output is Malibu. Whereas if it's not a function, here's the problem. Say my input is Toyota. The problem is there's two outputs for Toyota, and therefore this table does not represent a function. And the shortcut is you just pay attention to the inputs. Is there an input that repeats? Okay, in this one they're all different. The inputs are all different, that's why it is a function, whereas in this right example, Toyota repeats as an input, and thus it makes the table not a function. Okay, so that's how we see if a relation is a function or not a function if you have a table. Okay, pay attention to the inputs. The outputs could repeat. Okay, the output repeating is just like a vending machine that only has water bottles. No matter what you pick or no matter what you put in, you're gonna get a water bottle. Okay, the output is always gonna be a water bottle. Another way that we could represent, as we said earlier, is through ordered pairs. So again, these are two examples. This first one, this one here is a function. Because again, pay attention to the inputs. In an ordered pair, the first number represents the input, or the first object, thing. Okay, so CT, MA, ME, NH, RI, VT, these are again the states, the New England states mentioned earlier. These inputs are all different, therefore this is a function. Okay, on the other hand, the next set of ordered pairs is not a function, because look at these inputs, they're both CT, they're both Connecticut, and we can do this again. Here we have actually here another repeating input, California, and last one we have Colorado. Okay, either way, the point is that there is at least one input that repeated, and therefore this here does not represent a function. Okay, so pay attention to the inputs again, same as using the table. Ordered pairs follow the same idea, is that the inputs should not repeat in order for it to be a function. Let's see this other one, mapping, function again versus relation. So in this first one, which is a function, whatever month you pick, it's gonna point to a specific number. Say January points to 31, February 29, March 31, April 30, May 31, June 30, and July 31. Okay, so this is a function. There's no problem here. With the second one, again, this is not gonna be a function, not a function, because look at February. Okay, so if you pay attention to February, and the reason for this is, in this one I specifically chose 2016, and in 2016 February had 29 days, but in this one that is not a function, I did not indicate what year, and therefore February could have 28 days or 29 days. Since the input February has two outputs, namely 28 and 29, this is not again a function. Okay, see more. Now this graph, again, you can see this using input, using the inputs to check if it's a function or not a function. But we have a shortcut when it comes to graphs, and it's what we call the vertical line test. Okay, the idea is that, say this is a vertical line. Okay, it's an ugly vertical line, and I draw vertical lines like through it. Okay. So notice that wherever I draw a vertical line, I will only get to touch one point at a time. Okay, so this is a function. If you draw a vertical line, it should hit just one point at a time. Whereas in not a function, as you can see, if I draw a vertical line on this spot, or actually on this spot as well, the vertical line touches 2 points. So this violates what we call the vertical line test. Okay, and this one therefore is not a function because it fails what we call the vertical line test. Okay, for it to be a function, the vertical line says that the vertical line could only touch one point at a time. And lastly, we could also check those that are in words. So say, for example, is weight in pounds a function of weight in kilograms? Okay, the answer here is yes, because for every weight in kilograms, there's a corresponding weight in pounds. Okay, there's actually a table that I can show here. So say 10 kilograms is equivalent to 22.046 pounds. It would not be equivalent to any other weight in pounds. Same thing with, say, 40 kilograms. 40 kilograms is always going to be equivalent to 88.185 pounds. Okay, so this is a function. Now let's differentiate this with the other example. Is the amount in dollars a function of how many bills you have? Okay, and this is not a function. And the reason why it's not a function is, for example, you have 3 bills. Okay, say you have 3 bills, but these 3 bills can go many ways. Say, for example, the first case would be you have a 10, a 10, and a 20. So therefore, this could give you $40. But you could also have, say, 50, 10, and 5. Now you would have $65. And as you can see here, the amount changes. So you have 2 outputs, at least in this one, for the input 3. Okay, so the amount in dollars is not a function of how many bills you have. Okay, as we can see here, there's at least 2 ways that we could have 3 bills, and they would amount to different value in dollars. The first one being 40 and the other one being 65. Okay, so at this point, you should really know how to differentiate a function from not a function. And remember, these are all relations, and by that we only mean that there's a connection between the inputs and the outputs. They are related. And also keep in mind the definition of a function. For every input, there's exactly one output.